Okay, let's learn how to write a function that can compare two nested objects and also any two types. So here are my two objects with some crazy stuff like nan infinity, date, and a promise, null and undefined. So how do we do this? Well, first we get both object keys, compare the keys. If the keys are equal, then we do a recursive loop to compare each of the keys' values. So let's start with that. I'm going to delete this. And this is the first part of our code. I got two keys from both objects. Compare the keys. If the keys are not the same, we return false. If the keys are the same, we loop through one of the object's keys. And then as we're looping, we're going to recursively call this, passing in the value of object 1 at the current key, so we can compare it with object 2's value at the current key. Okay, and if any of these inside of this function returns false, we're going to return false as well. And if none of them return false, we're going to return true. If you look on the right, you're going to see we have a stack error. Why? Because when we recursively call this, we're not handling the evaluation correctly. So let's handle our comparisons. First of all, if obj1's value is the same type and value as obj2, then we're going to return true. Okay, so now we have true. One other thing we have to take care of is if we go down here and you see how G is null. Right now they're both null. So this first if statement will take care of that. But if only one of them is null, then we get an error because you can't get object keys from null. Okay? But we can take care of that by doing this. So if obj1 is double equals to null, remember double equals takes care of null and undefined. And if obj2 is equal to null, we return false. Okay, see, so now we don't get an error. Let me change this back to null, and we get true. Okay, now there's a few more types that we have to take care of. Let's take a look. Right now, b is 2. If I change it to 3, it should be false, but it's still true, right? So we have to take care of numbers, and then functions, and dates, and nan, right? It sounds really hard, but it's actually not that bad. Let's take care of the nans first. So how do we check for nans? So if string obj1 is equal to string nan, and then we can do the same thing for obj2. Okay? And then we can compare the nans by returning the stringified version of them. So let me copy this. Then we use triple equals and change this to obj2. Okay? So now let's take care of the numbers. Whoa, unexpected token 921. Whoa. Okay, so now I can say else if. We can check type number because nan is also type number. But another thing you can do is you can check to see if, hey, does obj1.2 fixed exist, right? Because all numbers have .2 fixed or obj2.2 fixed. Okay. If that exists, then we're just going to do a normal strict comparison between obj1 compared to obj2. Cool. So now if I change this 2 to a 3, we're going to get false. Okay. All right, now we haven't taken care of strings yet, but if I change the string, it'll be false. Huh. So JavaScript is taking care of that for us, and I'll talk about why later on. Now, let's take care of something else. So we did nan and numbers. Now, let me show you something. We can do const specials. Here's how we can take care of the functions and the symbols. Function, symbol. And then down here, you can do if specials dot includes what? obj1. Not obj1, type of obj1. Okay, and let me copy that. Or let me put this down here. Or includes type of obj2. Then how do we compare functions and symbols and stuff? Well, same thing. We can just return the stringified version of them, like so. Okay. So this actually takes care of functions, symbols, dates, and promises. Because if you do type of date or promise, you're going to see that it's also a function. Okay. So does this take care of everything? Let's see. So right now, if we do hi and we add an argument, we're going to get false. If we change this hi to also have the same argument, we get true, right? If we delete one value of this symbol, we get false. Put it back, true. Okay, now let's talk about strings. How come this string comparison is working, but we're actually not doing it ourselves? That's because of this right here. For some reason, you can do object.keys on a string, okay? And you can also do object.values. Now, if we leave it like this, every time we have a long string, it's going to do more recursive calls because it's only comparing each index at a time. Okay? Because when you use object.values, it breaks it into an array. But we don't want that. So up here in our specials, we can just add string. Okay? So now it's going to take care of this and compare all of the strings. And yes, you can stringify a string. That works too. All right, so now everything's returning true. If I change the date.now to just the date.now without calling it, it's false, right? If I change promise to promise.resolve, it's false. Okay, let's change it back. True. Now, the cool thing about this is not only does it compare nested objects, it can compare other values as well. Like if we compare two nans, it's actually true. A normal nan comparison would return false. You can even compare an array. So these are different arrays, so it's false. But if the values are the same, it's now true because type of array is actually object. So we're taking care of that too. All right, and that's actually it right here. Now, another thing that some students ask me is, hey, when we call this recursively and then this line hits true, doesn't everything just return true? And the answer is actually no, right? If inside this recursive thing, this is true, it's just going to move on to the next key, right? And the whole thing will only return true if none of the keys return false. So that's how it works. So you need this bottom statement return true and this top statement of return true as well, okay?